Hey again, Hawks. So as you can see, drawing ionic compounds is tedious. There's a lot of work to it. So instead, scientists use chemical formulas to indicate the compounds that are formed with ionic bonds. And so they're called ionic formulas. And again, we're going to be on our trek trying to figure out how are ionic compounds labeled and named. Okay. So at the end of this lesson, I will be able to write the correct formula and scientific name for common ionically bonded compounds. So as I said, writing things out this way seems a little bit tedious, right? It takes too much time. There's just so much detail. But writing a formula like this one is much easier. And so a chemical formula shows in shorthand the elements used to form the compound and how many of each of them there are. Okay, so in my example here, there are 2 sodium ions and 1 oxygen ion. Okay, in chemistry, we seem to not like the number 1. So whenever something comes up and like there's 1 of something, we just don't write the number 1 because we just kind of intrinsically know that there's only 1 of them. Okay, so in this example, we used 2 sodium ions and 1 oxygen ion. So to write a chemical formula, we would write the symbols for each of the elements used. So I used Na instead of sodium and O instead of oxygen. And we always start with the metal, right? We always put the metal as the first symbol, okay? Then we're going to add subscripts to indicate how many of each are used. So in this case, I put a subscript 2 to show that there are 2 sodium atoms. Okay. If the numbers match, then you're going to drop both of them. So if this was Na2O2, I would drop both of the 2's, right? So in my example here, I have a magnesium ion, which is a 2+, and I have an oxygen ion, which is 2-. It would take 2 magnesiums and 2 oxygens to form a bond. But we can just have a magnesium and an oxygen come close to each other and form a bond. So in this case, we're going to just drop the 2's and we're going to write it as MgO. And then if you notice, there's no space between the cation and the anion because this is all one name. It's all one compound. So there are no spaces in between. Okay, so let's look at an example. Write the correct formula when oxygen ions and aluminum ions form bonds. So I have aluminum and I have oxygen, right? An aluminum ion is a +3 ion and oxygen is a -2 ion. And remember, if I add those together, I get -2 and +3. So my overall charge is +1. So I don't have a compound yet. What if I add another oxygen ion? So if I add another oxygen ion, I now have -2 + 3 -2. So now my overall charge is not -1. It's still not 0 yet, so I still don't have a compound. What if we add, since this is negative, what if we add another positive ion, which is the aluminum? So now I have -2 +3 -2 +3, or I now have an overall charge of +2. So I still don't have a compound yet, right? Because I need this to be 0. But since this is a positive 2 and an oxygen is a minus 2, if I add another oxygen, I can get it to become 0. So now I have a full compound, right? I have ionic bonds in between each one of these atoms, or each one of these ions, and now I have enough of them that it now is going to create a compound. Okay? Now to write that formula, remember we start with the metal. So our metal was aluminum. So I'm going to put aluminum, and there are 2 of them. 1, 2. And so I put a 2 as a subscript because there are 2 aluminum ions. The second letter is O, and I'm going to write the 3 of them. So there are 3. My subscript is 3. So I have aluminum 2, oxygen 3. Okay, there is a quicker way to do this. If we write the each of the 2 ions, right? I write aluminum 3 plus and oxygen 2 minus, right? If I then take the number from the cation, so the number from the aluminum, and I transfer it down to the oxygen and write it as a subscript, then I can take the 2 from the oxygen and transfer it to the aluminum, okay? And so basically we're just switching the numbers. That's why we call it a switch trick. Then we eliminate the charges in the ions, okay? And if a number is 1, you just drop it, like MgCl2. But here I have Al2O3. So I've now switched those 2. I now have Al2O3. Okay. Again, if the numbers match, then you drop both of them. So if I was to switch trick this one, I would have Mg2O2. The 2's on the bottom are the same. So we're just going to throw those 2's out and make it MgO. If I'm using a polyatomic ion, I put parentheses around the polyatomic ion. So I'm going to do aluminum, which is a +3. And then here is sulfate, and sulfate is a -2. If I switch trick these, I end up with aluminum 2. So I need 2 aluminums and 3 sulfates. So notice that my SO3, on the outside of the parentheses, it says 3. The SO3 is one ion. It's one thing, right? So you're never going to break those up. You're just going to put parentheses around them and say, I need 3 of those. Okay? So now you should be able to correctly write ionic compound formulas using either the number method, like putting them together to make a complete compound, or you should be able to use the switch trick.